Hi students, I'm sorry I can't run a live lesson with you this week. It's just not possible, I'm afraid. So instead I've put together this PowerPoint for you which will cover all the work that you're expected to do this week for the pure side of your A-level maths course. You're going to be starting a new chapter called differentiation. Now this is completely new to you. It's a branch of mathematics called calculus. Its concepts are quite complicated and its applications can be difficult, but the process of differentiation is very straightforward. So what I'd like you to do first is go through the whole of this presentation where I'll introduce to you differentiation and show you how to differentiate. What I'd then like you to do is go to our Maths YouTube channel and look for the Core Year 1 Maths playlist. I have put links onto this PowerPoint for you. So I want you to watch the, say for example, the video I've recorded on exercise 12A. Make notes on the examples into your notebook as necessary, and then attempt the exercises in your on file paper. Please check answers against the answers in the back of the textbook, and if you have made any mistakes, have a look at the work solution on the online version of the textbook on Pearson Active Learn. If you then still just don't get a question, please just email your teacher and ask for assistance. Work through that to do exercises 12A, 12B, 12C, 12D, 12E. It should take you about 3 to 4 hours, I would estimate, and that will be all your work for pure mathematics this week. But before you do that, go through the rest of this PowerPoint, because I'm going to just introduce to you now differentiation and show you how to actually differentiate, because the process of differentiation is relatively straightforward. So, differentiating a function. So what I've got here is I've got some functions and what they differentiate to. So x squared differentiates to 2x, x cubed differentiates to 3x squared, x to the power 4 differentiates to 4x cubed, x to the power 5 differentiates to 5x to the power 4. So can you spot a pattern? What would x to the power 6 differentiate to? Well, clearly you should see the pattern. It should be very obvious to you. That's what's happening here is the power is coming in front of the x and the power is then reducing by 1. So we simply times by the power, reduce the power by 1. And that's it. That's all you need to know about how to differentiate a function. Times by the power, reduce the power by 1. That's something that you need to drill into your head. Some slightly more complicated ones. 2x cubed would differentiate to 6x squared, because 3 times 2 is 6, and then reduce the power by 1 down to a 2. 5x to the 4, 5 times 4 is 20, and then reduce the power by 1, so it's x cubed, 20x cubed. 7x to the power 6, what would that differentiate to? So you have a little bit of think. But it'll be 42x to the power of 5. Now, if a function has more than one term and can be split up by an add or subtract, you simply differentiate them separately. So, for example, x squared plus x cubed, well, x squared differentiates to 2x, x cubed differentiates to 3x squared, so in total it differentiates to 2x plus 3x squared. The second one I put up there, 5x cubed take away 3x to the power 6, we'll again differentiate them separately. That would differentiate to 15x squared take away 18x to the power 5. And then all you need to do, times by the power, reduce the power by 1. What about something like 5x though? Well, 5x is really 5x to the power of 1. So times by the power, 5 times 1 is 5. But when you reduce the power by 1, x to the power 1 goes to x to the power of 0. Well, anything to the power of 0 is 1, so 5x differentiates to 5. So any number x differentiates to that number. What about this one here? 3x squared plus 8x plus 2. Well, 3x squared differentiates to 6x, 8x differentiates to 8, but what about the 2? Because 2 doesn't have an x part, so I can differentiate it. Well, it actually does. 2 is really 2x to the power of 0, because remember x to the power of 0 is 1. So 2x to the power of 0, we times by the power, 2 times 0 is 0. There is no x term because it's 0. So any number on its own differentiates to 0 or just disappears in the process of differentiation. So 3x squared plus 8x differentiates to 6x plus 8. Now, what I suggest you do here is make a note of this in your notebooks under a title differentiation. Now y, if you've got y is a function of x, well y differentiates to what we call dy over dx, and that's just the notation. Y differentiates to dy dx. F of x differentiates to f dash of x, just slightly different notation. You can also say y differentiates to y dash. One dash means it's been differentiated once. So in general, if y is a x to the power n, then that differentiates to a times n, x to the power of n minus 1. Again, remembering all we're doing is times by the power of just the power by 1. And then I've put a note at the bottom just to remind you that any number x differentiates to that number, so ax differentiates to a, and any number differentiates to 0. Okay, make a note of that, please. Okay, final slide before you start 12a and go and watch the video on YouTube. First application differentiation, and this is how you're going to use differentiation in the year 1 course. Well, I said to you on the previous slide that y differentiates to dy dx in its notation. Well, there is an important reason behind that, because dy by dx is meaning the change in y over the change in x. Now, change in y over change in x is gradient. So when you have an equation of a line, if you differentiate it, it gives you an equation for its gradient. So for example, on the graph there, I've got the lines y equals 2x, 2x plus 3, 2x take away 2. All those lines are parallel. All of them have a gradient of 2, because if you remember, y equals mx plus c, and the number in front of the x is its gradient. Well, if you differentiate 2x, you get 2. If you differentiate 2x plus 3, you get 2, because 3 differentiates to 0. If you differentiate 2x take 2, again you get 2. So all of those equations each differentiate to 2. So when you differentiate an equation line, you get an equation for its gradient. In this case, you actually get its gradient. Okay, when you go on to 12a and watch the YouTube video, it then starts talking about gradients of curves and how we work them out. So that's the next thing to do. Good luck.